So now, on the first one, we say prove that triangle PQR is similar to triangle POT. So PQR and then triangle POT, the smaller one. So we want to prove if they are similar to each other. As I told you the last time, the conditions we're supposed to follow in this case, it's about proving that all sides are equal, or two sides and an angle is equal, or one side and two angles are equal, or all angles are equal. Whichever way you can prefer, it's going to be fine. Or depending on the information you are given. So you're supposed to prove like that. So, but now let's check the information we can use that is given from this. So we're given that this line is a diameter. It passed through the center of the circle. So if it is a diameter, we know the value of the angle for Q. What will be the value of Q in this case?
90.
Q is equal to 90 degrees. Why is 90 degrees? So it's because it's subtended by the diameter, right?
Yes.
That is the simple reason we can give about that. And then again, we are given angle O1, which is 90 degrees. So you need to indicate that this is a given angle. So you just write given. Okay, which other information do we have from this diagram? Because we're supposed to have three information with regard to this. We can have O2 in this case. What will be the angle O2? But let's check, we're interested to PTO and PQR. Therefore, O2 is not part of the angles we're dealing with. Okay, then now let's talk about angle P. What can we say about angle P? Angle P is what? It's common, right? Do you all see that?
Yes, yes.
Angle P is common because it belongs to this small triangle and also belongs to the big triangle. So P is common. Therefore, let's check the reasons. In this case, the first reason is that for bigger triangle, we have 90 degrees. And on the smaller triangle, we have a 90 degrees given there. So it's one angle. And then the second angle is that P is common in this case. Therefore, we are only left with one angle here, which we know that T1 will be equal to R. Why? Can you give a reason why T1 is equal to R? What would be the reason for T1 to be equal to R? These are what?
Angles in a triangle.
These are angles inside the triangle. Very true. Those are the angles inside the triangle. And therefore, with that information, we can then conclude that PQR is similar to triangle POT. Why? Because we have angle. Is there anyone who have a question with regard to question number 1 there? We are all fine, right?
Yes.
Okay, let's go to question number B, which talks about the calculation of PQ, PT, QT, and TO. So we're given that QR is equal to 12. This distance here is 12 units, and PR, this distance here, is equal to 20. So the first question requires us to PR is this one, right?
Yes.
PR is what? Is 20. So the first question requires us to find PQ. Is there anyone who have an idea of how we can find PQ? Remember already on the first question, we have identified that Q is 90. How
We
can
can use the Pythagoras theorem.
Very true. We're going to use Pythagoras theorem to find Q. And let me warn you that Pythagoras, it only works on the right angle triangle. We know we have right angle triangle if we have 90 degrees. So you must take note of that at all times. So here we can be able to apply Pythagoras theorem because we have right angle triangle. So now let's use Pythagoras theorem and see what you obtain. So it's going to be PQ squared plus QR squared is equal to PR squared. It's very important for you to be able to see that PR is the hypotenuse and this is the adjacent and that is the opposite. It's very important to identify that because you might not be able to get the correct value. So we are looking for PQ squared. You take this to the side, you're going to have PR squared minus QR squared, and then you substitute what you're given. In this case, PR is given as 20 squared, and then QR is 12 squared. Can you substitute that into your calculator and tell me what you obtain? What is 20 squared minus 12 squared?
256.
Is 256, and then how can we make PQ the substitute formula if we have PQ squared?
Introduce the square root sign both sides.
We have to introduce the square root both sides so that the square and the root cancels each other. So you will have PQ, which is equal to what? Can you put that into your calculator and tell me what you get?
16.
That is equal to 16. Are we all together with regard to that question we covered just now? Is it okay for everybody? Can we go to the second one?
Yes. Yes.
So the second question is about getting the value of PT. This one here. I can tell you that you can be able to get that question right by using the information on the first question of the similarity. So let's use that information of the similarity and see where we go with regard to that question. We are looking for this PT there. So it means here we have 90 degrees. Okay, we are given that. Okay, so what you're supposed to do there, you say PO divided by QR equal to TP, the one you are looking for, which is hypotenuse, in this case, divided by PI. Why? Why this is the case? Because triangle PQR is similar to the triangle POT. Ask me if you did not understand that. I will explain again. Are we all together with that fraction?
Yes. That's clear.
Okay. Then after having that, we can then make this the formula because it's what we are looking for. So PT is equal to PO divided by QR multiplied by PR, of which PO, I believe you can see what would be the value of PO. Is there anyone who can tell me what would be the value of PO?
Ten.
How did you get to 10? That is correct, but I will want to find out how it will be 10.
20 divided by 2.
Okay, very true, because we have a radius there. there's a relationship between radius and the diameter. So therefore, here we're going to have 10 divided by QR is given is 10, and then PR, we also calculated PR and we obtained 16. Can you put this into your calculator and tell me the answer you obtained? What is PT?
43 over 3.
Round it off.
13.
Yes, that is what I'm looking for. Okay, let's go to the next question, which is about finding this distance QT. Is there anyone who have an idea of how we can find this QT? QT is equal to PR minus PT. Do you agree with me? QT is equal to PR minus PT.
I don't understand.
Okay, it's coming from here. I said PT plus TQ is the same as PQ.
Yes.
So is PT plus TQ equal to PQ? With that, you agree, eh?
Yes.
And then we make this the same formula. We'll then obtain what we have.
Oh, okay.
Yes.
Got it.
Yeah, then let's substitute PR. We calculated it. Is it? Okay, let me check it again. Is QT equal to PQ? Here is Q minus PT, yes. And then PQ is given as 16 minus PT. We calculated it somewhere up here is from the previous question is 13. Therefore, the answer on that one is going to be QT equal to 3. So we obtained a value of 3 here. And for PT, we obtained a value of 13. Let me write those values so that it does not confuse us. And now let's go to the last question. Here already with 10. I believe you can be able to do the last question. How do you think you can be able to find the last question there?
We can use the Pythagoras theorem.
Very true. You use Pythagoras, you get the answer. So that is how we're supposed to do that question. Okay, others have left the meeting already because they are going to a science class, which is also taught by through Zoom. But otherwise, for today, this is what I wanted to cover with you. I decided to shift the questions because I noticed that some of you are asking me critical questions, of which I wanted to cover them with you in today's lesson. So for today, let's end here. I will discuss with you on WhatsApp of the suitable dates we can use from now going forward, because it seems that some of you are not able to attend because you are coming from school very late. So we'll discuss about the time and dates to meet, and we will agree on that. So I will announce when exactly we'll be able to facilitate our class going forward. But for today, let's end here. Okay, sharp, ne?
Sharp.